Welcome once again to the Hydrogen Fuel Cells and Batteries group exhibition here in the Hannover Fair. I hope you enjoyed it on yet, because the tables are completely full. If you like to have a new coffee or something to drink, the young girls are running here around to get you something to drink if you like to. Just give a sign. We have now the competition of research for the automotive fuel cells. I like to give a hand to Dr. Christopher Hebling, Research for Automotive and Fuel Cells, Director Division Energy Technology from the Fraunhofer-Institut, ESA.
Thank you. Thank you.
The ESA sounds easy in German. The ESA is developing, right? You're an institute making scientific things. So what is it?
So we're the Fraunhofer-Institut for Solar Energy Systems, so Institute for Solar Energy Systems. We are one out of 60 institutes of the Fraunhofer Society, and we perform applied research in the field of, obviously, solar energy, which covers energy converters such as photovoltaics, but also energy storage, energy efficient buildings, power electronics, the interaction of renewables with the grid, both with the electricity grid, but also with the generation of heat and the gas grid. And we right now have 1,300 scientists and engineers and students at the Institute, and all of them are focused on, as I said, energy efficiency, and also we do the hydrogen technology. That's what I'm responsible for, and that's why we're here. Hydrogen for us means, of course, the generation of hydrogen out of either hydrocarbons or water by means of PEM electrolysis, but also hydrogen storage and the conversion of hydrogen into heat and power.
So this is a very broad field, incomplete to see. I also heard that young scientific interested people want to get into your company, want to get into your laboratories to see how to work, and it's not very easy to get to you because you only take the best, I heard.
Well, we're indeed in the lucky position. We have about 180 PhD students and 250 master students in my institute. So, and if we have open positions, indeed, we get a lot applicants also worldwide that we can select the best. Yeah, so that's. But indeed, the PhD students are the scientific backbone of the ESA. That's right.
So you can promise a very concentrated work to everybody who wants to work together with you. Everybody who likes to have a project together with you, you can say that you got the best human material to work on it. Concentrating on the automotive, what is right now what is the interesting thing into your system?
Well, we consider mobility, especially the individual mobility by means of cars, as the true first markets with the scale effects. Because over the last decade, we talked about early markets or special markets such as backup power or micro fuel cell, portable fuel cells, which all of them did not make the market penetration yet. But as we all know, next year in 2015, we will see a high number of fuel cell cars on the streets. They will come from Asia, that's for sure. Mostly Toyota and Hyundai from Korea. They are about to manufacture the cars for the market introduction next year, and of course they now look for the best places to introduce their cars into the market. And of course, one of the first markets is California, but then Germany is also on the top level for the market introduction. And we want to be prepared to do the research for the development of the stacks and the fuel cell systems for the cars.
And are you prepared?
We are very well prepared.
Oh, very fine.
What a nice question. No, because we, as I said, strategically, we are focusing on automotive application, because there are basically, I mean, the three major challenges are performance, durability, and cost. And you can trickle down all the efforts of basically all manufacturers of fuel cell systems to these three components, because durability are very well related to like platinum or catalyst support degradation, a washout of platinum. The performance, it's always a trade-off between maximum performance on the one hand side and cost. If you have a high platinum loading as an example, then you have high costs, but to have both is really the challenge. But we try to face with all our equipments, and we did multi-million investments over the last couple of years for the power range of the car manufacturers in order to meet their demands. For example, a climate chamber, that's one of the challenges, because cars, as you know, they have to face all climates, which is sub-zero temperatures or high temperatures with high humidity levels, and the same car has to be able to start at minus temperatures, but also be able to face the other extremes. But even more so, the air quality is a big factor, because cars usually drive in cities predominantly, and the air quality in cities is degrading over the decades, as we know from the news. And so the fuel cells, of course, they consume the air from outside, and so we have to know really from a microscopic level the impact of all kinds of impurities from the air onto the electrode on the cathode side. That's what we try to quantify.
Yeah, so the quantification is the one thing. The calculation in complete going into the market with fuel cell in this direction, that you can see what kind of material is needed. What would you say is the main scientific challenge on getting a fuel cell into the market?
Oh, the main.
Or is there are so many there?
Yes, there are basically a lot of challenges. Well, the good news is that, yes, we will see cars on the road. We already have, on my campus, we built a solar hydrogen filling station. So we produce our hydrogen on site by means of PV on the top with then PEM electrolyzers, and we have two PEM fuel cell cars, Daimler B-class cars, which we run and operate every day. So it's a technology which works. So that's the good part of it. Of course, we know that they are still too expensive, and in order to meet the cost targets, as I said, we have to scale down the engineering and the materials and all that of such a system. So we address the topics of production technology. So we've just founded an industrial board of companies in the field, and with them we address exactly, all aspects of materials, of material handling, of stack manufacturing, up to the components and the system engineering of as a whole thing. So that's the cost thing. But if you ask about science, because we're scientists and I'm a physicist too, so the nicest to have would be a 3D modeling tool which integrates all the effects on all scales, because we have we start from the nanometer scale, because all the effects in an electrode, they're really in the sub-micrometer level. But on the other end, we're on the centimeter scale, and we have to cover all scales in terms of size, but also in terms of time, because some effects are in the microsecond speed, but some seconds, like water generation in a gas diffusion layer. This is more on the second and some second scale, and this is kind of a dream to have a simulation tool, and we work also with applied mathematics on such a development to connect the multi-physics simulation tool. But this is on the pretty much base science side. But as I said, we are facing the, as Fraunhofer, we completely live on contracts and ideally with companies. And so we have to support companies, and we do, and we want to support companies in their commercialization efforts. So if they have an issue with their flow field design, as an example, that in some areas they have dry out phenomena and in some the water agglomeration, so we can spatially resolve. We have, for example, one tool which is a multi impedance spectrometer. We have 68 different, separated spectrometers where we can do impedance spectroscopy on each area in one cell. So we segment like a car fuel cell is about this size. So we segment this in 68 different completely
Parts.
insulated segments, and with our spectrometers we can see exactly what's happening at which time in each segment, because we can apply a complete spectra from the 10 kilohertz to the subhertz range to each of these segments, and we can say exactly, you know, your flow field has some limitations in one corner or whatever else. So we try to cover the whole range from basic science to engineering.
So as I see here in the audience, several are looking very interested about this kind of scientific thinking about fuel cells. So you can simulate a lot. You can do a preparation for each kind of engine, special to the automotive range. So I would invite you, if you like, to talk to him. He's at the booth C58, so that's not far away. It's just there behind. And I'd like to thank you in joining this kind of discussion.
You're very welcome. Thank you for listening.
Dr. Hebling.
Thank you.